I'm going to show you how you can plot data. So the first thing you have to do is you have to import some libraries. One's called matplotlib, and this contains a lot of tools that you can use that somebody else has already figured out. MATLAB is a very important component of scientific data analysis, and you'll use it in college probably. So after we import MATLAB, we want to import matplotlib.pyplot. So this is the Python plotting routines from matplotlib, and I'm going to import that as p. So just instead of having to type out that whole thing, I'm just going to use p. Okay. So in order to plot something, the first thing you got to do is you got to have some data. So I'm going to have two lists. The first list is going to be called my X list, and that's going to start off being an empty list. And then Y list is also going to be an empty list. And now to give my list some data, I'm going to just make a quick little loop here. I'm going to say for I in range 0 to 20, for example. So I will go from 0 all the way to 19. And what I will do is I'll take xlist.append. I will add I to my X list, and my Y list I'll add I squared. Okay, so just a little. So when I'm done, I should have 0 through 19 in my list of X variables, and there are squareds in my Y variables. So that's not part of plotting, that's just getting some data. So here's how we plot. We created an object up here called P. So P is a Python plot. So I type p.plot, and I give it some arguments. The first thing I do is I pass it the list that contains the X values. Then I pass it the list that contains the Y values. And then I specify some plotting options. I'm going to have -ro to start with. Okay? And then I'm going to do p.savefig. So this is basically going to create the graph, and I'm going to call it graph.png. PNG. And so when I run this, if all goes well, I should end up with a graph. And there you go. So you see it down here. Here's the plot of my graph. So the X values were 0 through 19, and the Y values that are paired with them are the squareds, and so it's a parabola. There's a couple of features you can add here to make it a little fancier. By the way, you may have noticed over here it created a file called graph, and you can click on that to see the graph bigger. Clicking right here goes back to your code. Some things you can do, you can type p.xlabel, and you can pass it a label for the x-axis. So these are my integers, for example. And if I were to run that, it's a little small, but you can see down here there's a label that says p-labels. I'll make this a little bigger, and I'll hide that. So there you can see my graph a little bigger. It's got a label down here on the x-axis. You can do p.ylabel, squares of integers, for example. And that puts a label on the y-axis. p.title is, not surprisingly, the way to get the title. Cool stuff with Python will be my title. Other things that you might want to do, you can do p.grid, for example. And that would just make a grid. So now you'll see my graph has got a title and a grid. And there's lots of other things you can do that are fancy and fun. You can put all kinds of options in here. You can look up pyplot and get the user manual of all the hundreds of ways you can custom configure your data. But the cool thing about this is it'll plot as many points as you give it. So if I go from 0 to 200, for example, it'll just make a parabola that goes from 0 to 200 and plot all the points, and there it goes. So it doesn't really matter how big it is. It'll plot it. And then this graph right here, you can actually download it if you need to use it in a presentation or something. But right there is the code you need to, if you have your data in lists. So this part right here puts a list, but you might already have a list of some data, for example, from flipping coins. This right here is the basic way to plot it, and then this will show it. Okay, so this creates the plot in the memory of the computer, and this puts the plot on your screen. By the way, you can change these if you don't have any dashes. You could put, for example, GX. So if I go to GX and I go back just to the 20 integers and I run it, you'll notice that instead of red, it's green. So the G is for green, and the X shows the marker that is used. And you can add lots of different plots to the same grid if you want. So a single dash connects it all with a solid line. So there you go. That's the plotting in a nutshell.